All right, so this video is going over how to identify equivalent equations. So in doing this, we are going to be using our 4 properties of equality, our APO, our SPO, our MPO, and our DPO. Essentially, we are looking to see from the original problem, did they add the same thing to both sides? Did they subtract the same thing from both sides? Did they multiply? Did they divide by the same thing on both sides? If they didn't, then it's not going to be considered an equivalent equation. So if I look at the first option, I'm going to look and see, so they started with negative 66 equals ST. So I'm looking to notice what the differences are between the original and the new problem. So the difference I notice is this divided by 2. So if they divided ST by 2, DPO says that we also have to divide negative 66 by 2. So from here to here, they divided by 2. Negative 66 divided by 2 is negative 33. So this first one is an equivalent equation. Let's look at this next one. So I started with negative 66 equals S over T. To get from here to here, they divided by 22. So DPO says we also have to divide negative 66 by 22. That would give us negative 3, so that is equivalent. All right, let's check this next one. Negative 66 equals ST. What they did was they divided this side by 3 to get ST divided by 3. So we also divide here by 3. Negative 66 divided by 3 is negative 22. The last one, they went from negative 66 equals ST. They divided by negative 11 to get to here. If I divide by negative 11, I get positive 6. So this is not equal. Therefore, this is not an equivalent equation because this, to be equivalent, should have been positive 6 because I divided both sides by negative 11. Let's look at a couple more examples. Okay, so here they started with 6 plus x equals 9. So the new thing that I'm noticing is the plus 13. So to get from here to here, they added 13, so that's APO. They also needed to add 13 to this side to keep it balanced. So 6 plus 13 is 19, so that one is equivalent. In this one, so we have 6 plus x equals 9. They went and added 11 on this side. So to get from here to here, they did plus 11. If I do 6 plus 11, if I keep it balanced by doing the same thing on both sides, I do get 17, so that's equivalent. Let's look at the next option. And because it's a select all that apply, we have to check every single one of these. So I was at x, 6 plus x equals 9. And then to get to the new option, a 2 was added on this side. So APO says I also have to add 2 on this side. 6 plus 2 is 8. That is equivalent. And then if I look at this last one, how did I change from 6 plus x equals 9 to the new problem? Well, this time an additional 7 was added to the other side. So they added 7 on this side, which means they had to add 7 on the other side. 9 plus 7 is 16. So actually all 4 are equivalent because in all 4 cases, they APO'd the same number to both sides. All right, one more. So this one looks like another DPO problem. So let's see. In this problem, they divided both sides by 3. And negative 9 divided by 3 is negative 3. So we know that this is equivalent. if I were to divide by -3 on this side, -9 divided by -3 is not 4, so it's not going to be this one. Same thing here, if I divide by 3, -9 divided by 3 is not -4, so it's not this one. But -3 divided both sides for this one, -9 divided by -3 is +3, so it's this one. So it's the first one and the second one that produce equivalent equations when I do the same depot.